Hello and welcome back. Today we are going to talk about sampling and about how to find confidence interval when we do estimation. So let's begin with the idea of a sample because we talked about that, but I never explained to you what is the idea behind it. So we have entire population. We are trying to take a sample that will represent the entire population. We are upcoming election in the next year, and we are going to talk about taking a sample to predict who is going to be the next president. And last time in 2016, there was Trump versus Clinton. There was poll, and I want you to read about this, the review of sampling with regard to political prediction, who is going to be the next president, just to give you a hint or a better background on the subject. So, what is a sample and what is a sample distribution? The idea that we discussed in modules number 1 and 2 is the idea of the whole. The population is considered to be the entire universe. And so the objective of a sample is to capture a small group of subjects that represent accurately the entire universe. So a sample distribution is created by sampling. So typically we are interested in a sample distribution for the sample means and the sample proportions. So the method that we imply is the rule of probability or the law of the expected value of variance. So let's consider the role of 1 or 2 dice. So, example, there are 89 students in statistical class. The instructor wants 5 students form a project group. How should he proceed? So he has number of student ID, and what he needs to do is take each student number from 0 to 89, choose 5 pairs. If the number is between 19 and 0, choose another number. So the 5 numbers chosen from the group are the following. So this is the idea behind a procedure that is already known and established. This is the use of probability, random probability. However, as we learned beforehand, we also have the idea of non-probability sample. Because it is convenient to do that. Maybe it doesn't represent the entire population, but we were in the neighborhood and so we decided to do that. So this is the different type of samples, and I ask not to get confused because sometimes it's getting people talks about those two methodology in the same content. And so I ask you to be aware that probability random sample has a structure that can be stand with regard to numerical values. So under probability random sample, we have stratified random sample. We divided the population to subgroups or stara and select a sample random from each group. In cluster sample, we divided we divide the population to subgroups, and we select a simple random sample from the subgroup and take a sensor of every element in those groups. Again, there is methodology, there is idea behind it, and one in ink systematic sample is randomly select one of the first key element in order of the population and then select the K and the TH element afterwards. So again, a structure that can be repeated again. Example, divide Florida into counties and then take a sample random from each county. So again, a structure, or divide the Florida into counties and take a sample random of the 10 most popular counties. Again, structure that is really important. So I want to just to modify, or just to make sure, when we are talking about non-random sample plans, there are several other plans that are not involved in randomization, and that's the key element. They should not be used as statistical interference, which means their ability to take from the sample and predict about the entire population or about the future. So I went over that. I just want to make sure that all of us understand the idea and what it is with regard to sampling. Okay, so one of the things that we need to consist of or understand is, in the sampling procedure, we have to have a population and probability model that is from normal distribution. We use a random variable calculate from the sample, which is called the X bar, and they are related but they are not the same. For example, the average age of USF students population is 23.5, which is again the population, but the average age in any sample, X bar, is going to be different from the average population. So I hope that makes more sense. So now let's go to the sample distribution. Normal descriptive measure they calculate from the sample called statistics, and statistics vary from sample to sample, and here are random variable. So the probability distribution for statistics are called sample distribution. One of the things that it's really important, and one of the things that I'm really keen on, is that how do we measure if someone reported in a sample people like ice cream more than vegetables. So the issue is, in order for us to verify the sample, it has to be repeated. So if I will take a sample and then the next day I will take the same procedure, I ought to be finding the same outline, or the same result. So the sample distribution is statistics, the idea, what it stands for, and what the issue we are trying to do, where the size n are the repeatedly draw from the population. So if the population is 3, 5, 2, and 1, we draw a sample n is equal to 3 without a replacement, and that's what will happen. That's what the ability to apply that. So 10 is the 3 plus 5 plus 2 equal 10 divided by 3, the n, which is equal 3.33. And again, this is how I apply that. So each value in the X bar is equally likely within the probability of 1 divided by 4. Okay, so now when we are talking about different measurement of sample distribution, and it's taken from my book in page 127, we are talking about X bar and unbiased estimate of the U. So what is the U? Is the mean. And so the population value known as the population, the mu, the variance, the standard deviation, and the proportion. In the sample value, also known as statistics, we are talking about the X bar, also called, then we talking about the variance S square, the standard deviation is S, and the proportion is P. So again, from my textbook example, X and the sum, frequency and relative frequency, the mean of the entire population in this case is mu equal 2.2, and the variance is equal 18.48, and the standard deviation equal 3.993, because we need to square root the S in order for us to get 3.7. So how large is large when we are taking a sample? So If the sample has normal distribution, then the sample x bar distribution of will be normal, no matter what the sample size. But when we have the sample distribution under systematic, the distribution becomes more normal for a relative small value of n. So when the sample population is sketched, the sample size must be at least 30 before the sample distribution of x hat become normal. So this is how we find the probability. This is the formula for finding the sample mean, and this is where we are applying the z-score. In R, we do not have let me repeat that. In any textbook, traditional textbook, there was a table called z-score table. In R, we do not have that table, and we will see alternative way to find it. So, in order for us to find the z, a random sample n is equal 16 from a normal distribution equal 10, and the mean is equal 8. So the issue is, what we find out of it is that finding the probability of a sample mean equals 0.1587. So second example, a soda filling machine is supposed to fill cans of soda within 12 liquids ounces. Suppose that the fills are automatically distributed with a mean of 12.1 ounces and the standard deviation is 0.2 ounces. So the probability that the average fill a 6-pack of soda less than 12 ounce of soda. So the issue is, this is where we are coming into the game, and what do we need to do here? Again, apply the formula and calculate what it is stand for. And in this case, this is what we found. This is the essence of this module and the idea of finding this distribution. So the sample distribution of the sample proportion is the central limit theorem, and that can be used to conclude that binomial variable x is apparently normal when n is larger and the mean np and the standard deviation. The sample proportion, the p hat, equal x divided by n, is simply recalling of the normal binomial random variable x divided by n. So this is where we are at with regard to the idea. So p hat is equal x divided by n. This is what we are trying. If n is larger, then the p is too close to 0 or 1, and the sample distribution of p hat will be apparently normal. So the standard deviation of p hat is sometimes called the standard error of the p hat. This is the idea. So what is statistical process control? The case of a change of variable is to be ability to fill out to see what is correct and found what is the correct and find it. And other variation is also control is regularly as random variation. So the idea here is that if the process of variable is solely random, the process is said to be in control. In out of control, we must reduce the variance and get the measurement of the process variable within specific limitation. So as a result, we have rules. General rules is mu multiplied by x equal the mean. And so rule number 2, the q multiplied by x hat is equal to q divided by square root of the n. And rule number 3, when the population distribution is normal, the sample distribution of x is also normal for any sample size of n. And the last one is the issue of central limited theorem. When n is sufficiently large, the sample distribution of x is well appropriate by a normal distribution curve. So this is where we are finding. Again, example from my textbook. Suppose a team of research examined a type of book library borrow for the long Christmas holiday. So the research estimates the population of reader X has a normal distribution of mu, same as the X distribution, but the standard deviation is similar than the mean. As a result, the team raises the question, what is the relationship where a random library user will borrow a book that can be classified between the language, marked by 5 different classification of language, and technology, also classified as 7 different types. So we have in library catalog, we usually have classification based on the type of book. Example, general 1 or 0 is a general works, 2 is philosophy and psychology, 3 is religious, and so on and so on. So the answer is x1 is equal 8, x2 is equal 10. So the issue here, again, I remind you, is that the z-score is the something that we are trying to achieve. In order for us to do that, and we are looking at the z-score table. If you will search z-score table, you will get those results and you'll be able to match to see what it is entail. So the calculation of z variable, where x, we subtract the ux and divide it by qx, and this is how we do that if we do not have the z-score in hand. Last issue that we need to talk about is the standard error. And if it is the standard deviation of a sample distribution of the mean, and the formula for standard error of the mean is where the q is the standard deviation of the original distribution and n is the sample size. And the formula does not assume that there is a normal distribution that we are having here. So there are many of the use of the formula in order to assume a normal distribution. This formula shows that the larger sample size, the smaller the standard error of the mean. More specifically, the size of the standard error of the mean is inversely proportional to the square root of the sample size. Okay, in R, how do we measure the standard error? We have the container, in this case, the sample that we like to do. We are using the function of CE and CD. CE is the standard error. CD is the standard deviation. So what do? I apply the CE, and then I will take the CD of the formula of the standard deviation x divided by square root of the length of x in order for me to calculate the value of the standard error. The preview of the central limit theorem is again the idea of how can we capture that and what it means with regard to the outline. Some observation is central at the same place is 0.5, and with the distribution in draw towards the center, that means that the standard deviation is decreasing, can be disqualified this. So in this case, this is what we are apparently seeing in the case of this distribution. So estimation is the proportion of the statistic to estimate the population. The sample's mean is used to estimate the population mean. The sample proportion is the estimate of the population proportion. In statistics, that can be the nature are the variable and the proportion are the fixed. Some of the questions that we always need to ask ourselves, what hope that the sample proportion is close to the population proportion? How close we can expect it to be? Will it worth would it be worth to collect larger sample or smaller sample? How much closer? So the sample distribution of statistic is the idea of distribution of the value of statistic over all possible size as a sample size of n of the proportion. And the idea is that let p, the proportion, be a fixed value, and let p hat be the sample proportion. So in this case, this is where we are looking at. And suppose in this class, 3/4 are freshmen. So suppose we will take a sample of 2 students to select to find the p proportion. So in this case, this is what we will need to do. So again, this is the outline of what we are doing. Let's take another example. And let's go back to the example of the freshman in the sample. And again, in this case, how we are applying it, and the size, when the size of the sample is 3. And again, this is how they apply in order for us to apply to it. But suppose we have a survey, and suppose we have 51 of the population playing to vote for a candidate 8. So the p is equal 0.51. What is the probability that exit survey of 1,000 people would show the candidate X will vote or show support for candidate X with less than 45%, that is, the p hat smaller than 0.45. So again, the issue is we have to describe the population. We have to know the sample size, in this case is 1,000, and the p is equal 0.51. In order for us to pursue, in order for us to find out what it is. In the textbook, I also provide with a central limited distribution. I will use R to illustrate it, where the command R norm is to draw 500 numbers, random numbers, that, well, the mean is equal 100 and the standard deviation is equal to 0. So we will start with the population. We will review 5 random systematic, and then we move the sample distribution. I recommend you a general proportion that will be the rule number 1, 2, 3, and 4 as outlined in the sample. I also outlined for you an example or outline how to find confidence interval with R. So we outline what is the value of X, and this is the value of X. I jumped, instead of writing you how I entered this data, I already embedded into it. So in this case, assume that the normal distributed is unknown mean and the standard deviation is $15,000. So again, the X bar, and this is how I frame it. And we know that the n is equal 10 and the given sigma is equal 15,000. So in this case, the mean alpha is 0.5. So we get the Z alpha divided by 2. And from R, the Q norm will give me this ability to apply and find out what it is. So the sample average is, and in this case, the X mean X in this case, and the sample error, I call it me, and I will say 1.166, which I found above, multiplied by the entire set, 50,000, divided by square root 10 in order for me to calculate, and the lower and the upper boundaries as we saw in the distribution. That's what we are trying to find. And in order for us to secure our finding, 90% of it, and so we will find the 95%, the alpha, in order for us to, if we expect to replace the z-score of 0.05, and in this case what we will add be able to apply it in order for you to do that. So you have this. I want you to go over that. I also scratched the histogram X and normal distribution. The question that I'm going to ask you is two questions. One is about a publishing company that is just publish a new textbook, and they are looking to see what is the right price. They collected 25 other similar books and see the price. And so the idea here is how to construct a 90% confident interval for the mean price of such textbook. I gave you what is known and what is n, and I gave you, so n is equal 25. What you're looking for is to find the value of x hat and the number of q. And the question number 2 is the confidence level of 90%. The second question, the same formula, but in this case, again, the issue is checking. Whenever time I learned today that every time I check my bank, the bank actually pay a fee for that. So I did a question. Let's see if it makes sense to you, and make a 99 confidence interval of the current mean of annual cost to major banks of such checking account, and this is what we do. Let me know if this makes sense, if it give you an indication of what it is. Until next time, have fun and enjoy.